Welcome to the Azure Sphere RemoteX project, which is a remote peripheral access solution. So RemoteX consists of two network-connected components. The first is RemoteX Server, which runs on an Azure Sphere device, and its role is to listen on a network socket for incoming API requests. The second component is the RemoteX Client Library, which is called from a desktop POSIX C application. And its role is to implement a shim for all of the Azure Sphere high-level peripheral APIs. And the role of this library is to provide transparent remote access to Azure Sphere hardware. Now, the goal of RemoteX is around improving developer productivity and application quality. And now for a demo to help you understand how RemoteX works. So the code I'm going to be using for this demo, you'll find in the repo linked below. I've also got this link in the end of the slides. So I've got the Hello World example set up from that repo. So I want to talk about the hardware first. So I've got an AVNet board here, and on the AVNet board, I've got a click relay. And connected to that relay, I've got a light, which is just sitting off to the left. Now the other peripheral I'm going to be using is button A. Okay, back in Visual Studio Code, I want to talk a bit about the application. So as I mentioned in the previous slide, you need to be building a POSIX C application on your desktop. Now the reason for this is ultimately this code is going to be executing as a high-level application on the Azure Sphere. And a high-level Azure Sphere application is a POSIX C application. Now on Windows, the easiest way to go and build a POSIX C application is using Windows Subsystem for Linux. And you'll see down the bottom left-hand corner, I've got Visual Studio Code connected to WSL and the Ubuntu instance that I'm running. I can also go and build a POSIX C application on obviously desktop Linux as well as Mac OS. Okay, so what I'm going to do now is I'm going to run this application. So I'm going to press F5, which I've done. And the first thing you'll notice is how quickly that application starts. And I hit that breakpoint. Now, the reason for this, of course, is because this application is running on my desktop. So what I'm going to do now is step into init peripherals and handlers. So I'll step on into that. And the first thing I'm going to do is execute the Azure Sphere high-level API called GPIO open as output. And I'm going to open the relay, which is living on pin 0. So I'm going to execute this API. Now what happened is that got marshaled across my Wi-Fi network and was picked up by the RemoteX.server, which is running on the Azure Sphere device. The API was executed, and then results from that API are returned back to my desktop application. And if I hover over the file descriptor for relay, you'll see it's returned back the file descriptor of 9. I'm going to do the same for opening up button A. Okay, so we've now got the file descriptors back for both the relay and for the button. Next thing I want to do is I want to go and check the state of button A. So I'm going to step into this function called getGPIO_state. So I step on there, I'm going to step over this code, and the next thing I'm going to execute is the Azure Sphere high-level API to get the state of the GPIO, the button. So I'm going to execute that API. So remember what's happening is that this request has been marshaled across my Wi-Fi network to the Azure Sphere where it's being executed, and then the results are being returned back to my desktop application. I'm going to step out of this application and I'm going to click on continue. Okay, so the next thing I'm going to do is I'm going to put a breakpoint at line 32. And what I'm going to do is press button A on the Azure Sphere board. And you'll see that it's now hit the breakpoint inside this block. And the next thing I'm going to do is I'm going to toggle the state of the relay. So I'm going to call the Azure Sphere high-level API for GPIO set value. So remember what's happening. This has been marshaled across the network to the Azure Sphere device, and that API is being executed and the results are being returned back. Okay, the next thing I'm going to do is do a log debug. And I'm just going to print out the message button pressed, and we're going to say which button, with the count for button presses. So I'm going to execute that, and you'll see down in the terminal, I've got button pressed. Okay, so I'm just going to click on continue, and then I'm going to remove all of the breakpoints. Okay, so I'm going to come back to the AVNet board, and I'm going to click on button A again, and you can see that now that light is being toggled on and off. So in summary, with RemoteX, you're getting a super fast developer in a loop. That whole coding, testing, debugging, the amount of time you spend on that significantly reduces. You get source code compatibility with the Azure Sphere high-level peripheral APIs, as well as remember you're building a POSIX compliant application. You get access to more advanced tooling like memory profiling and testing frameworks, as well as this project is being community maintained, so you can also contribute to that project. That also, of course, means that there is no official support for RemoteX. Now, the other thing I should point out with RemoteX development is you still need to be thinking like an embedded developer. If you think about your desktop environment relative to your embedded device, you've got near enough to infinite amount of memory. So obviously on Azure Sphere, where you have a reduced memory footprint, you still need to be thinking about the amount of memory that you're allocating. Now you need access to a Unix-like developer environment. Now on Windows, that will be WSL, or you could have a Linux desktop, or do it inside Docker or Mac OS. Now, of course, there is an overhead. There is a network overhead, round-trip overhead for each API request that you're making to the Azure Sphere device. I've measured it. It's not super scientific, but it's on the order of 3 milliseconds. Do give RemoteX a go. Do try the examples and be sure to feedback. So you can feedback either via Twitter, so I'm dglover on Twitter, or leave issues or feedback on the issues tag for the examples. So give it a go, have fun, and save yourself some time building Azure Sphere applications. Thanks so much.